Okay. So hello everyone. As usual, let me see if there are any questions before we start. For the lab, each time we create a new set from two existing sets, should we add existing nodes into the new set or create new nodes? Yeah, whether it's union or intersection. For sure, you have to create new nodes, Mark, because this is a new set, right? You shouldn't be referring to the nodes of the original sets. Otherwise, now you will mix them up, right? You have to have separate nodes such that it represents what we call a deep copy in case you copy, but this is not necessarily for the copy. The rule is it has to be a different set, right? Michael, let me see. Did you upload the tutorial and lecture video from Friday? Not yet, Michael. I had a problem with my video editing software, but hopefully I will do it today. Ian, does the efficiency portion for the union intersection imply that we cannot use add or remove functions? So, well, the problem with add or remove, Ian, is that you will be searching. So, well, it's different, right? Because union and intersection, you can leverage that the both fits are sorted, and then you can just append to from the beginning, for example, or from the end, whatever direction you would like to do. But not each time you add, you don't need to traverse the whole list. While for the add case or the remove case, you take a target as an input as well to the method, and you'll be searching for this target to insert after, or to add, or to remove, right? So simply add and remove in this case is less efficient, because in worst case you have to traverse the whole set or the whole linked list, right? So yes, don't use them because they are inefficient in that case. And the implementation of union and intersection can simply be much simpler because, well, you can always append either from the beginning or from the end, right? Are we allowed to use the dot length for arrays in the lab? Yes, you are allowed to do so. Michael, for constructor 2, can we use the, yeah, okay, yeah. What is the format of final exam? Do we have multiple choice questions? Snigda. So, well, so that's a question that I know the problem with 2SH4 is that it's like at the first day of the exams, right? So you need this information as soon as possible, and I acknowledge that. The problem is I don't want to keep changing the environment for you guys. Like, I want to keep what we have used for midterm, which is GitHub. Whether we will have multiple choice questions or not, this will depend on how easier I can test concepts from Java. But hopefully, so let's do the following. So the plan is today we are going to finish all the technical content. Hopefully also today's lecture is short. Starting from next lecture, we will start focusing more on answering these questions. Do exercises on the final exam, solve with you some problems, see what the environment will look like, and how to, basically how many questions you might have, because I didn't board the exam yet, to be honest, right? So give me until, well, not tomorrow, maybe give me until Friday, and I will give you a very clear and detailed answer. And I will also post an announcement about this, right? With details, similar to what I have done for the midterm. Could you further clarify what an efficient method means? So simply in programming, and that's a very important question. So let me leave this to last, because also it's a technical question and I want to elaborate more on this, given that this is the last lecture. Will you post the tutorial from Friday? Yes, Abigail, I will post this and lecture as well, hopefully today after this lecture. Good. So let me go back to this question. What is an efficient method? If there are no more, oh, there is one extra question. How high do you have to get the drop a lab? Sorry, Nicole, what you mean by that? I'm not getting your question. So hopefully if you can clarify, I can try to answer that. So what is an efficient method? So what is efficiency in software engineering? Maybe the shortest answer for this is efficiency means you do the minimal required work. For example, let's apply this to the lab. You want to find the unary intersection and create a new list that holds these values, right? Um, well, I can do this in a very inefficient way, in the sense that each time I can use my add method. And that means now each time I might need to start from the head, because add starts from the head, keep looking for an item, and then until you hit whatever the end should be, and then you add this new node, which means each time, each step in your iteration, each new node added to the new set, you would have to traverse the whole set, right? While on the other hand, if you know that your both lists are sorted, you can leverage this extra information to always append from the head, for example, or append from the tail, which tail means the end of the list, which means, well, you don't need to traverse at all, right? So you are saving yourself n time traversal if you have n nodes. This is what we mean by efficiency in software engineering. Basically, do the minimal required work. If there is a solution that has less computation than another solution, this solution is said to be more efficient because it requires less computation resources. This is runtime efficiency. On the other hand, there is also space efficiency, which means, well, I can solve this problem by defining a set, creating it, and then copying it in another set. But that means now you define two linked lists in the memory, you utilize more memory, and that means your solution is not efficient. Some of the problems you have for arrays, especially, might be very easily solved by, and you find these problems usually in interviews as well. So you can solve the problem very easily by just creating a copy of the array and then keep, for example, sorting the array in that copy. But that's inefficient solution from the space perspective because, well, you create a duplicate of the array. So if you have 1,000 element array, you have to have 1,000 elements array in the memory as well, which is very inefficient. If you have million elements, you have to have million elements. While if you can solve what people call in place, which means you don't create another array, but you sort your array in the same array, that's space efficient. So usually in software engineering, there is space efficiency and runtime efficiency. Space efficiency related to the memory, how much extra memory you need. Runtime efficiency means how long you need to run, how much computation, which is usually defined as how many traversals, for example, for your linked list, or how many loops you need to do, or loop iterations. That's runtime efficiency. Well, TOSH, because this is almost the first programming course you would have in CompEng, I mean, beside the first year Python course, it doesn't cover in detail those kind of concepts, but TOSI, because it's more related to data structures and the algorithms, hopefully will cover this kind of notations in a more detailed way. But for now, this is, given that maybe you'd be doing interviews before taking TOSI, this is what you need to know about efficiency in my point of view. Okay, so Nicole, I guess you didn't clarify the question, so once you do this, maybe I'll try to revisit it. If you refer to what I said before by saying, when I look into the total lab, all the labs, like the 6 labs, and take the best 5, if you are referring to this, then basically the rule is you submit a lab and you attempt all the questions, and, well, maybe let's say if the mark is out of 70, if you get at least 60, then this lab can be dropped. But so why I'm doing this? Because, for example, one can say, well, I have already submitted the past 5 labs. I'm not even going to submit the 6th, given that already the first 5 will be taken into consideration. That's not the case. In order to leverage this, I would say more relaxation in lab grading, you have to attempt all the labs, and you have to have good standing on all the labs, right? How much exactly, this will depend on when I look into the lab grades. But I just want to let you know that this option exists. Like, basically, if you lost a couple of grades here or there in a lab, you shouldn't worry about it. This was okay, good. So it seemed that this is what you pointed, what you meant by that. So the main point I'm trying to make for those who didn't, I would say, know that I have said this before. Simply, if you lost a couple of grades in any lab, or you lost some grades in one lab and you are doing well in all other labs, don't worry about this, because maybe at the end I will just ignore these grades you lost, and then you will take the best 5, right? While if you just don't attempt any of the labs, you don't leverage this thing. Basically, you get 0 in this lab, right? Okay, so I hope that's clear. So these slides are already uploaded. As I said, today is the last technical lecture. I have already posted an announcement on Avenue for what is the plan until the end of the course. Simply after today, starting tomorrow, we'll start looking into questions, maybe exercising for the final, and maybe do more coding with you, such that I make sure you guys are. I will focus more on how to approach a problem. So simply you get a question in the exam, how to think about it, how to approach it, and how to manage your, I would say, time and resources way of thinking to make sure you do reasonably well answering this question. Good. So interfaces. So last time we discussed abstract classes, and we said, well, abstract class is a special sort of aberrant class that adds an extra constraint. So simply abstract classes are coming from inheritance. It's a parent class or a superclass, but the constraint that an abstract class puts on any child, well, do you remember from last week? What is the extra constraint that defining a parent class as abstract adds on top of the constraints for a child class? They have to implement the abstract methods. Exactly, Yolanda. Thank you. So you are forced to implement or override all, Arjun, thanks. You have to override all the methods that are declared as abstract in the parent class. Otherwise, the child has to be abstract as well. Good. So we kind of define, we said the main use case for this is you define the interface, you define the contract with the user, and then the child will be implementing the details of the methods that are defining this contract. And then we had a question of, well, can an abstract class has concrete methods? Concrete means with implementation, and we said yes, you can have concrete methods. So as far as you have at least one abstract method, you declare yourself as abstract class, which means the abstract class right now, yes, it boasts this constraint, but still has the flexibility to have implementations for methods, right? So it's a mix between a regular concrete class and inheritance, as well as abstract methods with no implementation. While let's take this one step further. So the way I would like to think about these kind of things in Java especially is we started by concrete classes. With regard to inheritance, a concrete class means all methods have implementation, but the child still has the option to override them. And then last lecture, we moved one step forward and we said, we define what we call an abstract class. And this abstract class gives you the option to obligate, to enforce that child implement certain methods. And today, we are even taking this one step further, more abstraction, and we define what we call an interface class. As you will see, it will seem from the first glance that interface and abstract classes are almost doing the same thing, but there are differences we will enforce right now. So the way you should approach this is interface classes are more abstract than abstract classes. Like simply, they have no implementation at all. Abstract classes can still have implementations for concrete methods, while interface is not. And from the name, interface class is simply the reason we have interface classes is you define the contract or the interface with the user, right? So the same idea of abstract data type or ADT that we started from. Okay. Good. So again, coming from the mentality of ADT, the interface class defines the protocol of behavior, the contract with the user, which you can implement using different ways, right? And simply what we do inside the interface class is we declare the set of methods, but we don't implement them. Now we are enforced not having implementations at all. In abstract classes, you can have concrete methods. In interface classes, you cannot. So you only declare the methods, but you don't define them. The child class that is a child of an interface class, now we don't call this extents. It's still the inheritance relationship, but we call it implements. Why? Because you are enforced to implement all these methods. So when we use the reserved word implements, it means that a class is implementing an interface. Good. And once a class is declared to implement another interface, well, you are enforced to implement all the methods of this interface. Okay. So again, an interface is a set of methods without implementation, and we have to declare them both as public and abstract. First of all, why do we have to declare them as public? Because the mentality is that those methods are the interface with the user. So the user wants to use them. And on the same time, those methods have to be implemented by the child that implements the interface. So they have to be public to be able to get used. And then they have to be abstract. Well, why that's the case? Because we said interfaces have no implementation, which means, well, the methods have to be abstract. So this is with regard to methods. What about variables, or what about instance fields? An interface, you can have instance fields, but those instance fields have to be final and static, right? Which means, well, you don't change them. So these are the rules. We will go right now into examples, but the rules, from these rules, let's now differentiate this from the abstract class. The main difference is in an interface, you are not allowed to contain any instance fields or methods with implementation, while in the abstract class, we were allowed to define variables, if you remember, in instance fields, and also we had some implementations or some concrete methods, while interfaces is not allowed. So the use case is the same thing, the abstraction idea, the ADT, the thing that you have, you differentiate between what is the contract with the user space. This is the user space. This is your implementation space. And here you have this interface. Both abstract classes and interface classes are concerned with this area where you define the contract. These are the things you find in a documentation of a software, but it doesn't tell you how these things are implemented. With regard to details comparing interface and abstract classes, let's take the components one by one. With regard to variables, in an abstract class, well, you can have any kind of variables, public, private, whatever, because it's a normal class. While in an interface, you only can have public, static, final variables, as we said, which means they are constants, they cannot change, right? With regard to constructors, in an abstract class, we can have constructors, right? And if you don't define one, there is a default one, the empty one that initializes everything to 0 or null. While in an interface, you cannot have constructors. Why that's the case? Because, well, you cannot create objects out of this interface class, and it's not meant to be, right? So as we will see right now, well, you don't even inherit those constructors. So the class that implements the interface will not be calling the constructor of the interface. With regard to methods, abstract class can have, well, abstract methods as well as concrete methods. As far as you have only one abstract method, you are an abstract class, while in interface class, all the methods have to be public and abstract. Okay. So again, with regard to the use case, the interface can be used similar to the abstract class, and we already went through the differences. So let's have an example, but let me beg questions if you have questions. I will go back to this lab for mark problem. I don't know why they are not. I will check what is the problem with Avenue, but if you have technical questions with regard to this slide before we go into the example, please ask. Okay, maybe there is a delay. Let's wait for a few other seconds. Okay, so if you remember what we have coded in first of all, we started from inheritance. We have this graphic object or shape parent class that we define the circle, rectangle, point, whatever out of. And then last lecture, we have declared this as abstract because we didn't want to implement the area method. Right now, we will declare this as an interface, which means, well, I cannot have any implementation. It's just the area or the toString. Last lecture, if you remember, we defined the area method as abstract, but we implemented another method, like the toString, for example, and it was a concrete method, just to show you that it's possible to have both abstract methods as well as concrete methods in abstract class. While for the interface, everything has to be abstract, right? Okay. So one thing to mention here is Well, because we define this as an interface class, Java JVM compiler knows that every method and all the variables, so all the methods have to be public abstract and all the variables has to be public static final. That means, to simplify, you can just remove all these specifiers, right? So you just simply define the variables as you define them in a normal program, just using the end type and then the return type for the method. So you don't need public abstract for the method or public static final for the instant variables. As far as you have this interface keyword before the class name, I mean, the compiler knows that all the methods have to be public abstract. Good. So by doing this, we want to, so simply we define this interface, which means it tells me that I have an ADT, abstract data type, that is called shape. This shape has to provide the user with two methods, area as well as getName. And it also has a variable that is called k, right? And you have to explain what is the usage of k. Public static final int, but int in interface, yeah, it's still public static final, but you don't have to write it anyhow. That's correct. So good. So right now, by just defining this interface, we define the contract, but we didn't say how we implement this because this will depend on the shape, right? So if we want to implement a shape interface, we can write something like, let's leave this for now. I will come back into this because it's a more detailed one, but let's look into the rectangle case, right? In the rectangle class, right now I use the reserved word implements, not extends, because you have to implement all the methods of the shape. And then, so what does this imply? You have to have an implementation for the area as well as the getName, right? In the area, well, I just return the length by the width. And for the string, I just return rectangle. This is the name of the shape, right? So by implementing all the methods, well, it's just fine to define it as public class. The first question we have is, what if I didn't define one of these methods or didn't implement one of the methods? What do you think might happen in that case from what we have seen last lecture? Compiler error, that's correct. But what would be the error or how to fix it in other words? What do you think? In the meantime, I'll be opening online GDB and see what you guys think. So let me see in the chat. Write an implementation or make method abstract. Exactly, Yolanda. And then if I make the method abstract, well, I will get another error. What would be the error? So let me share with you the online GDB one. That's the rectangle one. So if you have an abstract method in your class and you just define it as public class, what would be the problem with that? You would have to make both the interface and the child abstract to avoid their exactly Arjun. Sagnan, the same thing, thanks. Katie, class isn't abstract would be the error. Exactly, Katie, thanks. So you have, if you have an abstract method, you have to define your, so I hope you are able to see this online GDB thing. So going back to the question, here this rectangle class is implementing, just make bigger. This rectangle class is implementing the shape interface. And well, it has an implementation for all the methods. Let me just fix this. And the question that I had is, what if we don't have one implementation? For example, I have something like that, which means, well, I define the area as just normal thing, and then I run. Well, area is missing method body or declare abstract, which we have seen last time. If I define it as abstract, so let me go back to the shape. Well, the shape is still defining it here. Define it as abstract. In this case, I have one abstract method, and the rule we said is, well, rectangle is not an abstract class while you have an abstract method, so you have to define it as abstract, right? And in this case, this is the rule. If you have a child that is implementing an interface, but it doesn't implement all the methods, it has to be abstract. Good. Just go back to the implementation we have. Good. Questions in that case? The keyword for an interface class is interface. That's correct, Yolanda. So here, right? So it's an interface. But, well, I cannot define rectangle as an interface because it has some implementations. So in this case, it tells you have to define it as abstract, right? If this was the confusion you have. Okay, good. So now let's see if I want to use this to just show you the usage. It's exactly the same way as we had in the abstract class case. So maybe in the main, I want to define something like that. I go to the main. Let me just remove this printing. Let's use this template thing. Okay, so we didn't define the new circle yet. So let me just define this as also rectangle. And okay, maybe I just leave it as 2 and 2 in that case. So what I'm doing right here is simply so similar to what we have done last time. We have defined 100 array elements of our graphic object. In this case, I call it shape. That the name doesn't really matter. I'm defining an array of 2 elements of the interface shape, and then when I create the objects, they have to be of the child type. So here we only have one child, which is rectangle. Oh, come on, which is rectangle. And then I call the area methods of this rectangle. So this is how we use it. That seems normal. And simply the area one in the rectangle will be called. One thing to show you is, similar to the abstract class, you cannot really define objects of an interface because simply it has no implementation for the methods. So if I try something like, so let's first try this one to show you that it's working and then go to the case that is not working. Well, it did run, but do I implement something? Because I didn't show the area, so maybe maximization is just this problem. Okay, so let me system.out print line, then sum equal, and then sum. Okay, so if I run something like this, so in this case, you get the sum, right? Which is the sum of the area of the 2 rectangles, right? So it works fine, right? So just to show you that what is the problem, or we cannot create an object out of an interface class similar to the abstract case, I might want to define this as shape, right? And then in this case, well, let's say there is an empty constructor, and then I'll try to run, right? Oh, it tells you shape is abstract, cannot be instantiated. Here it's just mixing abstract and interface for this online compiler, but doesn't really matter. It tells you, well, both things, you cannot create objects out of them, right? So if that's the case, maybe something I want to ask you what might be confusing. So first of all, what is the lesson here? You cannot really create objects out of either abstract class or interface class, right? Similar to what we have seen last time and this time as well. But then the question that I have to you, if I cannot create objects of an interface class, what I'm doing right here, right? I'm using the word new, and it seems to me that it creates shape, right here, shape. So aren't we here creating objects of the interface shape? What do you think? What do you think? So what are we doing in this line 13? Aren't we creating objects of the interface shape? Well, AK, you are close. That's creating references of shape. Character, you are closer. That's correct. But yeah, these references are what? Like simply, no, we are just allocating memory for interface shape and the subclass objects. So simply what we are creating here is the array itself. Remember in Java, you need to allocate the memory for the array, and the array itself holds the references, not the objects, right? So it's similar to, remember we had the array of addressees in pointers for C. You declare an array of addressees and then you declare the objects in another array level, right? 2D memory allocation lecture we had. It's exactly the same thing. This line is creating the array for references of type shape, and we said you can define a reference of type shape, that's fine. And then afterwards, these two lines are creating the actual objects, which was like supposed to be rectangle in this case, right? This, we cannot have this as shape. Good. Okay, so with regard to the question is what is the word implements does, simply previously for inheritance, we had to write extends. It's a keyword for a child inheriting a parent. Here, it's the keyword for a class implementing an interface, right? And this keyword is exactly the same thing as inheritance. So simply the implementation, a class is implementing an interface, has exactly the same relationship of inheritance, which is the is-a relationship. So an object of type rectangle is also an object of type shape, right? So this is what allows us to do what we are doing right here, right? Is referring to the reference of type shape for an object of the type rectangle or child, right? Good. So what else do I want to show as what are some of the other capabilities of an interface? Assume I want to write another class, and let me just copy this here. Oh, that I call, I don't know, my circle. And then, well, I didn't have a point class, but let me say here, I define also the point class. And then, well, for the point class, what do we need? We need X and Y, I guess. So let's say public class point. Then I hope, remember that it was int X and Y. When we have the getters, are we using any of these here? Well, we have at least the constructor that takes two inputs. So here I have to define point. Well, let me see. Public point, it takes int x1 and y1. And then I'm assigning x equal x1, y equal y1. What I'm writing right here is that the simplest class we have wrote back, I guess, a month ago, which is the point class that has the coordinates x and y. I'm only defining the constructor that takes like two int values, and returns like assign this to x and y. Why I'm doing this? Because here my circle is simply referring to the super A and B. I will explain this right now, but simply just uses this constructor here. And then, well, this is the get name methodology, and this is the area, method, and the area method. Good. So what are we doing here? It's one of the powerful things about an interface is previously, maybe I go to the PowerPoint to explain this to you. New slide. Previously, one thing I mentioned to you, I guess the first lecture of inheritance, I said, well, a child can inherit a parent. This parent can have another parent. This is one form of relationship. We also know that, how to get the thing to change the color. And then we know that another form of relationship is, it's like you have a brother or sister. A parent can have another child here, right? And one clear example for this is the graphic object has circle and rectangle and triangle, whatever, right? So that's also allowed. One thing we said is not allowed in Java, while it's allowed in other languages like C++. Do you remember what was that? Having multiple parents, Yolanda, thanks. Ian, no, grandparents are allowed in Java, Ian, right? Here, we said all the parent, like simply all the classes are childs of the object class, but then you can have like you can have parent, grandparent. So this chain is fine, right? But you cannot have multiple parents. I guess this is what you are referring to. So something we said is not allowed is this child. Well, this child cannot have another parent here, parent 2. That's not allowed in Java, right? We said this might be allowed in C++ or other languages. While inheritance in Java is just a one-to-one relationship, right? What if I want to just simulate something like this? I want a class to take some methods from one class and other methods from another class. Interfaces in Java allows you to do so. Simply, you can have, so what is the rule? Let me stay in the same graph here. If this parent, so simply, well, this can be even like a normal parent class, but as far as all these other parents are abstract, interfaces, that's allowed, right? So in Java, a class, a child cannot have two concrete parents or two abstract parents, but you can have multiple interfaces. Why that's the case? So let me ask you why this might seem logical. Because let me wait for a couple of seconds and see what you guys think. Why interfaces are kind of less strict in that sense? Is well, a child can implement multiple interfaces while it cannot inherit multiple parents. What do you think? Why it might be easier for a language, for example? Just guess, like try to think, right? Try to think what is the difference between this case and the other case? Step parent, because the form of implementation is not strict. Well, it's more strict. Right, that's an interesting discussion. You are close, right, in terms of what you can do on it. Or that's well, you are both saying the same thing but in different ways. Only one parent so that the compiler wouldn't what class to access when you inherit or use the keyword super. That's one reason you'll end up. An excellent point is that, well, super is only referring to one parent. That's one point. So what is interesting about interface classes, by like just based on what we discussed so far? The interesting thing about an interface, it has no implementation at all, correct? Which means you know that the parent class is really not giving you a certain implementation, right? It only gives you the contract, right? Multiple contracts are not colliding, right? So simply, as far as I don't implement anything, well, I'm leaving this for the child to implement it. While for a concrete class, you have implementations. And what if you have a method with the same name but different implementation? Which one to use? Now there is no rule, right? So, well, in C++, there are different ways of doing this, but we're talking about Java here, how to handle this. So it's a less complex case in the sense that all these ones, you really don't have any implementation, which means that it's up to the child to simply implement the methods in a certain way. So you don't have two different implementations for the same method, correct? While talking about concrete parents, two concrete parents that are not interfaces, I can have the chance that there is a probability, well, there are two methods implemented in two different ways, which one to call, and I need to handle this case, right? So, well, what you guys said is about it's more strict in the sense that, well, you are enforced to implement them, but it's less strict in the sense that I don't enforce an implementation on you, so you are free to implement yourself. That's the main point. So Java is using, if you want, you can have a child that simply, to some extent, inherit multiple classes if those classes are interfaces. And there is one example. You can simply have something like a child that's called B class that extends A class. So what is this relationship? This is the inheritance relationship because we are using the reserved word extends, which means this A class can either be concrete or, what do you think? Abstract, right? While all, and then it can still implement multiple interfaces, in fact, not just one, right? Good. So one example for this is what we have here for the point class. For the myCircle class. So remember, let me call this myCircle. In the myCircle class, we used it at the first inheritance lecture to extend the point class. But right now, we also make it to implement the shape because simply a circle can extend a point class by putting multiple points in a certain shape, while it can implement the shape class by implementing both its methods, right? Get name and area, right? So that's an allowed thing to do. This has to be myCircle. So right now, if I use super AB, which one I'm referring to? What do you think? Point class constructor. Point. Correct. Exactly correct. Why not the shape class? What do you think? Why you said point, not the shape? Super is used for inheritance. Yes, but the interface relationship, we said, is also an inheritance. It doesn't have a constructor. That's correct, Mark. So we said interfaces don't have constructors, and that's the main point. So simply super is referring to a constructor of the parent, but shape, even an interface, doesn't have any constructor. So you are referring to the point. So what we do here is we initialize x and y and radius by assigning the radius value and then the super of x and y, which is going here and assigning x and y. So simply super there is calling this constructor. This is the reason why I implemented it. And then this is the part that is implementing the shape interface, right? Because you have the area and the get name. Good. So if I do something like this, I go to the main right now to show you also the capability of this abstract data type. One thing can be, I can leave this to be a rectangle or make it myCircle. In this case, I need to send 3 points, the radius and x and y. And in rectangle, I'm sending only 2 points. So here, I'm defining 2-element array. The first one is going to be myCircle. The second one is going to be rectangle. And then I'm adding their areas. Well, what did we call this? I'm using exactly the same method twice, but each time, or maybe let me first ask this question, which area method is going to be called in array 0.area? What do you think? In the one that I'm highlighting right now, which area method is going to be called? The myCircle one, correct? Why? Because this object, area 0, is a myCircle type. What about this one? It's going to be the rectangle one, right? Then the question is, well, what did we call this? Using exactly the same method, the same way, but you call different method in runtime. Polymorphism, yes. Thanks, Yolanda. And dynamic method binding, both are referring to the same thing in this example. Perfect. And in this case, if we run this, hopefully we shouldn't have any problem. Well, we do have a problem because myCircle should be capital C here. Well, and then you just get the sum of the summation of both, right? So questions? So the concept, if you got the abstract class concept, it's simply just a slight delta extension, right? It just you move more towards the way of thinking of the differentiation between ADT, like the actual contract or interface with the user, and the implementation that you have, right? That's the whole point behind this interface class. No questions? We only use the implements keyword with interface classes, right? Yeah, yes, Arjun. Implements is just you. Implements is referring to your parent is an interface. You cannot use it for a normal, concrete, or abstract class. That's correct. Okay, other questions? So we are done with the technical content. So I would say, well, we are done 7 minutes early. That's a record, I guess. Arjun, we only use the implements keyword with yeah. Does it matter whether we say implements or extends first if we are using both? Well, let's do that. It can't be, right? Why that's the case? Because, well, if you have this two relationship, let me go back to this one. Oh no, not this one, the full screen one. Do I still have the figure? Yeah, here. If we go back to this one, well, this is the extents relationship. And you can only have one extents, right? But you know that you might expect different implements. While if you have implements, well, you know that you are implementing this class, so you are not expecting the extents related reserved word, right? So you have to have it such that you first define the inheritance relationship and then the implementation of the interface class relationship. Yeah, Nicholas was highlighting the same point. That's correct. Questions? What are some applications of interface classes, Sandy? That's a good question. It's the same application that we were referring to when we talked about you need to differentiate or decouple the abstract data type, the contract with the user, from the actual implementation. So if you are like a company for software development and you are developing something for a user, and the first thing you do is you said with the user, you ask him or her for requirements, it gives you the requirements. The first deliverable you have to give to the user in that case is the contract, right? Simply, I'm giving you those methods, you have to use them in this way. Do you agree or do you want modifications, right? If the customer agrees, this customer can be a big company or a single customer, it doesn't really matter. If he agrees or she agrees, then this is your interface. So simply interface classes are more usable in the sense that it's the actual contract, right? While abstract classes, well, they can be used as a contract, but they have the option to define concrete methods as well. So if you are looking for flexibility to implement some methods but not implement others, then interface cannot be used. But if you are only defining the strict contract which shouldn't have any implementations, then interface should be used, right? That's the different use case between interface and abstract class. Okay, more questions? The child of an interface class can be abstract. Yes, Yolanda, right? This is what we have done for the rectangle, if I remember, right? We said if we don't implement this one has to be declared as abstract. And in this case, you will get an error. Otherwise, you define this one as abstract, right? And in this, it should work fine. But in this case, we cannot really instantiate it here, right? So this one wouldn't work, right? But simply you can have something like this. So the rule is, if the class, the child that is implementing the interface is not implementing all the methods, it has to be abstract, right? Why? Because abstract class is enforcing the child's, I mean, if you inherit this child with another child or grandchild, the grandchild has to implement the abstract methods. Is there a performance advantage of using interface classes versus abstract classes versus concrete? How much does having multiple implements affect performance? So Arjun, that's a good question. So the whole point of inheritance is not necessarily related, well, it intersects, but it's not necessarily related to the performance point of view. Maybe a good efficiency point of view, something like this. By inheritance, but both abstract and interface classes allows you to do this dynamic method binding. So it makes your code more readable and dynamic, but it's not about running time. It's not about performance, right? It's more about the mentality or the paradigm of thinking on bigger projects. What is really the interface or the contract and what is the implementation? And I gave multiple examples before. And one clear example that you guys are using in the last lab is you are using the LL node and singly linked list classes to implement a set, while in one of our lectures, we used both to implement a list, right? So the same implementation can apply to multiple abstract data types, list, set, sequence, whatever. And at the same time, the same abstract data type, a list, for example, can be implemented using multiple implementations. Something like a list can be implemented using an array, a linked list, or even a tree, or like hash table, things you will see later in data structures. So differentiating between the actual implementation and the abstract data type that the customer sees and uses, this is the main mentality behind object-oriented programming as a whole, right? So you'll find if you look into all the lectures, it's almost every time we mention this, right? Everything is servicing this kind of mentality or mindset, which is think about what is the interface with the user, what the user wants, what is the usability, what you want to give the user to use, and what is the implementation. If you mix both, then, well, you have security problems, integrability problems, extension problems, like versioning, all the things we have discussed multiple times before. But if you don't mix them, you have the flexibility, you can update your code later without bothering the user, and you have compatibility, all the things, and security as well, because you don't expose your implementation to the outside world. All those benefits we discussed for the object-oriented programming mentality. Good. Questions? Okay, so if there are no more questions, again, today is the last technical lecture. Starting tomorrow, we'll start working through. Yeah, Nicholas, I have already answered this efficiency question. I just like spent 5 minutes discussing this at the beginning. So starting tomorrow, we will start looking into exercise questions, how to approach the exam, and maybe hopefully give more details and review of what we have discussed, especially the Java part. Thanks everyone, and see you all tomorrow. Oh, by the way, I will not have office hours for today, because also I will start from tomorrow using the lectures to take more questions, because we are reviewing basically. But today I have a conference to attend, so I cannot be on office hours. So thanks everyone, and see you all tomorrow then. Have a good day.
Excuse me.